Hi everyone, welcome back. In this video, we're going to take a look at how to factor quadratics using the area model. So let's take a look at a quick example. We know how to factor using greatest common factor. Sometimes we'll be presented a polynomial, however, where we can't factor it just by finding the greatest common factor. Let's take a look at a quick example of x plus 2 times x plus 3. We know from polynomial multiplication, we can multiply this out, and we'll end up with x squared plus 5x plus 6. So that is the result of these two factors. In other words, here we have our product, and here we have the two factors. Let's assume we're given the product, and then we're being asked to factor the product. So let's say we're given x squared plus 5x plus 6. Well, we know we can rewrite this as two factors because we did the work above. We know that we could go backwards here and rewrite it as x plus 2 times x plus 3. But the issue here is we don't know how to work backwards. How do we go from that right side to the left side? And in this case, we can't just use common factors because x squared, 5x, and 6 don't share any common factors. 1 is the greatest common factor. So we can't use greatest common factors to factor here. What we're going to use instead is the area model to help us work backwards and find out what those original two factors actually were. Okay, let's write out our area model quick. So we have our 4 squares. We know that our final product is x squared plus 5x plus 6. And looking at our area model, we know that the x squared, the first term, goes in this box, this top left box. We know that the last term, 6, is going to go in this box. A few other areas we could fill out. We know that x squared is just x times x. So we have x's there. However, we actually don't know what we can put in these two boxes that are remaining. And the reason why is we know they're going to add up to 5x, but there are different ways we could split this up. Is it 4x and 1x? Is it 3x and 2x? How do we want to split this up? And when we have higher numbers, there's a lot of different ways we could split it up too. What we're going to do is use what we know about the area model to figure out how do we find these two numbers that we split the middle term into. We know a few pieces of information about these two numbers. So first, we know that the two numbers add to the middle term of our product. So the two numbers add to the middle term. In this case, what that means is that the two numbers, I'm just shortening it here, add to our middle term here is 5x, add to 5. And let's just talk about the coefficients in this case, 5, because we know we're going to have an x here and here because of the sides we already filled out. So we're just trying to find those coefficients, the numbers in front. So we know the two numbers add up to the middle term, so they add to 5. Another piece of information we know is that the two numbers, because the two numbers are going to appear here and here, when we multiply them, we end up with 6. So our two numbers also multiply to give us the last term. So multiply to, in this case, 6. So our two numbers multiply to 6. And this is going to be true for all quadratics that we work with, except for if we have coefficients in front of the x squared. We'll talk a little bit later about what to do in that situation. For now, we're just looking at, let's say we start off with an x squared, and then we have some other parts for a quadratic. How do we factor these types of quadratics? So x squared plus something times some, plus something. Okay, so we can use these two clues to find out what the two missing numbers are. The easiest way that I find to start off with is to start off with actually letter B and then work our way from there. So in this example, we know that the two numbers multiply to 6. So what I'm going to do is take a look at 6 and find all of the factors of 6. We know 6 is equal to 6 times 1. 6 is also equal to 2 times 3. And here it's actually important, we'll see in a bit, we also want to include negative factors too. Negative 6 times negative 1, because a negative times a negative gives us a positive. Negative 2 times negative 3. And what I'm going to do is for all of these sets of factors, I'm going to find the sum of these factors and then see which of these factors have a sum that is 5. Sum. So 6 plus 1 is 7, so it's not 5. 2 times 3 is 5, so we're done. If we wanted to add the other ones, we would get -7 and -5. So 2 and 3 multiply to 6, and they add to 5. So 2 and 3 are the missing numbers in this puzzle. Okay, so 2 here, 3 here. It doesn't matter which order we put them in, as long as we put a 2 somewhere, 3 in the other spot. Finally, what we're going to do is finish filling out this puzzle by finding the blank spots. The blank spots, one way to find it is just to find common factors of 2x and 6. So in this case, we know that 2 goes into 2x and 6, so we're looking at the greatest common factor, so plus 2. And then for the last one, we look at this and say, what do we need to multiply to get 3x? What do we multiply by x to get 3x? Or what do we multiply by 2 to get 6? And we know that's 3. And going through the rows and the columns is going to help us out when we have some more complicated factoring. The 2 numbers you find are also just, in this case, going to be the 2 numbers that you have on the outside here, the 2 and the 3. Okay, great. So that's it. X plus 2 times x plus 3. We have found out that for x squared plus 5x plus 6, if we're being asked to factor, we can rewrite this as x plus 2 times x plus 3. And that's our final answer. All right, so we figured out how we can work backwards, start off with a quadratic product, and rewrite it as its binomial factors, how to find the 2 factors. Okay, let's take a look at a couple of examples so get some practice with factoring quadratics using the area model. Let's start off with example 1. Let's take a look at factoring the quadratic x squared plus 3x plus 2 for our first example. Okay, so here we're going to draw out our area model. And the reason why we're going through the area model and doing all of these steps is because it's going to help us out for these situations, but it's also going to help us out when we get into more complicated factoring. So there is a reason why we're drawing out the area model and filling out the entire puzzle. So we have our area model. We know that our final product is going to be x squared plus 3x plus 2. We can fill out the x squared in the top left. It means we can also fill out these 2 x's. And then we know that 2 is going to be in the bottom right corner. And what we're missing are the coefficients for these 2 missing boxes. Okay, we have 2 pieces of information. We know that they they add to the middle term. So in this case, they add to 3. We also know that they multiply to the last term, to 2. So this one's pretty easy because we could start off by looking at factors of 2. Well, 2 can be written as 2 times 1 or -2 times -1. So really easy, just 2 sets of factors. We'll take a look at the sums for both of those factors. 2 times 1 is 3, so we're finished. The other one would be -3. So 2 and 1 are the missing numbers, missing coefficients. Let's go ahead and write those in. 2x and 1x. Finally, we're going to fill out the rest of the puzzle, the 2 missing spots here and here. Looking down our column, 2x and 2 share a factor of 2. It's our greatest common factor, so we can do x plus 2. And then finally, 2 times what gives us 2? Well, 2 times 1 gives us 2. So we know 1 is in that missing spot in the bottom left. So finally, our answer for factoring x squared plus 3x plus 2 is going to be the sides, x plus 2 times x plus 1. Okay, so a really quick example. We didn't have a lot of factors to look at, so this one was really simple to get through. We just needed to find factors of 2 that add up to 3 and then fill in the boxes. Let's do another example. Here we have example 2, and we're going to look at x squared minus x minus 12. So the next examples are going to be a little bit more work than that first example, which was pretty straightforward. Okay, let's start off like we did in the previous examples by writing our area model, writing down that our product is x squared minus x minus 12. Filling in the 2 boxes we do know, x squared, and it's important that we carry over the sign, the positive or the negative. So here, the bottom right is going to be -12. So not just 12, but -12. We know we have an x here and an x here. Finally, we're trying to find these missing boxes and missing coefficients for these boxes. Again, we have our two pieces of information that are going to help us out. First, we know that the numbers add to the middle term. In this case, our middle coefficient is -1, -1x. They add to -1. So again, it's important that we carry over the negative or the positive. We also know that they multiply to -12. So add to -1, multiply to -12. Okay, so what we're going to do is take a look at -12 and let's find all of the factors of -12. Well, we know -12 is equal to -12 times 1. We could also do 12 times -1. We have 6 times -2. We have -2 times 6. We have 3 times -4. And -3 times 4. So here 12 has a lot of factors, so a little bit more writing. For all of these, let's go ahead and find the sum. Well, -12 and 1, the sum we end up with is -11, so that's not the case. They add to -1. 12 and -1, we get 11. 6 and -2 gives us 4. -2 plus 6 gives us, oops, I wrote the same exact factors here. We would have -6 and 2. -6 times 2. Okay, so -6 and 2. When we add those up, we get -4. 3 and -4 give us -1. And we're done. We found our two numbers that multiply to -12 and add to -1. The last one would just give us 1. So 3 and -4 are the two numbers we're looking for. So again, it doesn't matter which box we put which. Let's put the -4 here and the 3 here. Next, looking down our column, we have -4x and -12. The greatest common factor, they both share a factor of -2, but they also share a factor of -4. Another way to think about it is they share a factor of 4 and they also share a negative, so they share a factor of -1. So -4 is their greatest common factor. We're going to write -4 on the outside. Finally, for this missing spot on the left, we're looking at what times -4 gives us -12, and that's going to be +3. So we've filled out our missing spots. Finally, we can write down our answer. X squared minus x minus 12 is equal to x minus 4 times x plus 3. So in this example, the negatives were really important because they helped us find the two factors that add to -1. Okay, let's take a look at one more example. Here we are given x squared minus 9x plus 20. Okay, so just like before, write out our area model. We know the product is equal to x squared minus 9x plus 20. We know we have an x squared here, a 20 here. We have x's in these spots and up here, and we're missing our coefficients. So again, our two pieces of information. We know our two numbers add to the middle term, which is -9. And they multiply to the last term. Multiply to 20. So again, we'll start off with 20, find all of our factors. Well, we have 20 and 1. We also have -20 and -1. We have 10 and 2. -10 and -2. We have 5 and 4. And finally, -5 and -4. So again, we can take a look at all of these and find the sums for each of these. Here we have 21, -21, 12, -12, 9, and -9. And we found our pair of numbers that add up to -9. That's -5 and -4. So here both of our numbers are negative. Let's go ahead and write those in. -5, -4. Finally, looking at common factors, -5, x, and 20. They both share a factor of 5, and they also both share a negative. And then we multiply -5 by what to end up with 20? Well, we multiply it by -4 to end up with a +20. We found our missing parts, so we can at last rewrite x squared minus 9x plus 20 as x minus 5 times x minus 4. Okay. So in this video, we took a look at some examples, how we can start off with a quadratic trinomial, and without using greatest common factors, how we can rewrite it, factor it, in other words, rewrite it as its factors, rewrite it as a factor of two binomials. And we do that by setting up the area model and using those two pieces of information, that adding to the middle term, multiplying to the last term, to figure out what the missing numbers are.